So in this exercise, we're going to talk about bone healing by callus formation, which occurs during indirect bone healing. Now I have this little gadget, which is a model of a fracture, and you see we have a very unstable fracture here. This demonstrates the instability which occurs after a fracture has taken place. Now, in the fracture zone, a hematoma develops, which contains lots of cells that are precursors for bony cells, which will heal the bone. Now, what does nature do? Nature starts building a callus by increasing the diameter of the fracture zone. And by doing this, now you see we have more relative stability, meaning there is more stiffness in the fracture zone, and this stiffness increases with time because at first we have a soft callus, which is like gel. Then this increases in stiffness by becoming a hard callus or a callus which has more fibrous tissue. And this fibrous tissue with time calcifies in order to develop the bone, which can be seen on your radiograph. Now, the increase of stiffness can be demonstrated, and I'm putting a little bit of vacuum in the fracture zone. Now, if I let go, you see, now we have a hard callus, and this hard callus has increased the stiffness to a measure of stability which can enable the bone to be loaded. So now we have the situation of a healed bone with a large bony callus. And after a certain time, it can take up to 2 years or even longer, the bone remodels. I'm going to demonstrate the remodeling by taking out some of the vacuum, and you can pull back the beads, and I will manually remodel this just to demonstrate what happens. So after 2 years, the form of the bone has reconstituted itself, and now you have a stable bone. Now we have seen how callus formation heals a bone by indirect bone healing. Now let's look at the tissue which is involved in indirect bone healing when we have relative stability. Now I have a little gadget here which demonstrates a normal fracture which has different gap widths. Now in the static situation, this is a bone which will heal. There is 1 cell in this small gap, there are 2 cells in the medium gap, and 3 cells in the wide gap. Now this can heal well, but in an indirect type of bone healing with relative stability, we have micro-movement. Now, I will demonstrate micro-movement by sliding this part back and forth. And now you can see how the strain differs from gap width to gap width. Now in the top, you see a very small gap, and if the strain is too large, this cell will probably break and will not contribute to bone healing. But in this type of a fracture, we have other parts which will heal well because the strain is distributed among very many cells, and each cell can withstand the strain of the micro-movement, which is also needed for bone healing. So in the end, it really doesn't matter if 1 or 2 cells break, because with time, the callus will encompass all of this area and will heal the bone. So now let us discuss the results of this exercise and what you can learn.
In the online faculty support packages, you can find faculty guides for each station and, where appropriate, topics for discussion and frequently asked questions. In case of questions, please send an email to templates@aotrauma.org.